Good morning students, this is Latif sir. In this video today I'll discuss how to extract different metals. According to the syllabus, according to the reduced syllabus, you have to read about the extraction of zinc, iron and silver. Okay, and in the first video on metallurgy I have told that how to extract a metal and the different steps of extraction of metal. That is, the first step is crushing and grinding, and then second step concentration of the crushed ore, and in third step conversion of metal ore into oxide form, that is calcination and roasting. After that, the main step of extraction of metal, that is reduction of metal oxide into metal. And after this, after getting the metal, impure metal or crude metal, you have to refine the metal. Okay, and I have told different methods. I have discussed in the previous live class, how many methods of refining of a metal are there. Okay, so in this video today I'll discuss how to extract different metals like copper, zinc, silver, Fe separately. Okay, so first seek extraction of copper. The main ores of copper. The main ore of copper is copper pyrites. You know that, CuFeH2. Copper pyrites is the main ore of copper, and you can extract copper from these copper pyrites. Okay, so extraction of copper. So first you have to get the concentrated ore, roasted ore, and during roasting process is same. First you have to take the ore of copper, that is copper pyrites. Then you have to crush the copper pyrites ore. Then you have to concentrate the copper pyrites ore using fourth flotation. Okay, after fourth flotation you have to roast the copper pyrites ore to get copper oxide. Okay, so the sulfide ore of copper are roasted to give oxide. Roasting means heating of the concentrated ore in presence of excess air. When copper pyrites, which consist of copper sulfide Cu2s, and as a impurity FeS2, FeS is there. FeS is present, ferrous sulfide is present as impurity in copper pyrites ore. Okay, so during roasting, copper sulfide will be converted into copper oxide, and after this, copper oxide can be reduced by auto oxidation method, or you can also reduce copper oxide using carbon reduction method. Okay, so the oxide obtained after roasting of copper sulfide you can reduce using carbon. Okay, so oxide ore can then be easily reduced to metallic copper using coke. Okay, so Cu2O plus C implies Cu plus Co. You will get metallic copper after reduction of copper oxide using carbon. In this method, in the extraction of copper, impurities ferrous sulfide is present, that is which during roasting of copper sulfide ore, that is sulfide ore of copper pyrites, the copper sulfide will be converted into copper oxide. During roasting, copper sulfide will be converted into copper oxide. Okay, and the copper impurity like copper oxide are removed as a slag by reacting with silica. So in this in the extraction of copper from copper pyrites, silica SiO2 is used as flax. It is act as flax, which removes the impurity iron oxide as a slag. So FeO is impurity. It is actually a basic impurity. To remove this basic impurity, an acidic flax SiO2 acts as flax, which is used to remove the impurity FeO as a slag, and FeSiO3, which is a slag, okay, which is a lighter compound which will be separated from the metal ore. It will float over the metal, liquid metal. So during extraction of copper you have to use silica as a flax. It will react with impurity FeO and it will form slag FeSiO3, which will be lighter material and will be float over the liquid copper metal, okay, and it will be separated easily. Now see what is blister copper. Blister copper is the impure copper is known as blister copper, okay. So the solidified copper obtained after extraction has blistered appearance due to the evolution of SO2 is called blister copper, okay. During the reduction of copper using carbon, SO2 gas will be evolved, and the copper ore and the copper metal obtained after solidification has blistered appearance due to evolution of SO2 gas, and this copper is known as blister copper. It is actually the impure copper which is obtained after reduction, okay, and which has blistered appearance. Now one question: copper can be extracted by hydrometallurgy but not zinc, not required, okay. You can. And how is copper extracted from low grade ores? Not required, okay. Now say, state the role of silica in metallurgy of copper. What is the role of silica in metallurgy of copper? Okay, silica SiO2 used as flax. SiO2 is used as flax. It removes the impurity, basic impurity FeO present in sulfide ore. Okay, so during the roasting of copper pyrites, a mixture of FeO and CO2 is obtained. The silica acts as flax which reacts with impurity FeO forming slag, FeSiO3. Okay, FeSiO3 is slag. Okay. Why copper matte is put in silica line converter? Same answer. Copper matte contains impure coppers, that is the copper matte contains copper sulfide and ferrous sulfide. Copper matte is put in a silica line converter to remove the remaining FeO and FeS present in the matte as slag, FeSiO3. Also from silica also some silica is added to silica line converter, then a hot air blast is blown. As a result, the remaining FeS and FeO are converted to iron silicate, and CO2S is converted into metallic copper. Okay, so silica is actually used to remove the impurity FeS, FeO present in copper matte. Okay, so the reactions also given: formation of slag, FeO plus silica reacts together to form slag, FeSiO3. Okay, and during this process copper sulfide will react with oxygen. During roasting it will be converted into copper oxide, and copper oxide will be, and remaining copper sulfide will be reduced by copper oxide. This is auto reduction. This is, in this case, this is auto reduction or self reduction. Auto reduction or self reduction. First copper sulfide will be roasted and it will be converted into copper oxide partially, and the copper oxide will be reduced will reduce the remaining copper sulfide into copper. Okay, this is actually auto reduction. Okay, now see extraction of zinc. How to extract zinc? Zinc blende. The main ore of zinc is ZnS, zinc blende. So ZnS, from zinc blende you can extract zinc metal. So first you have to do the crushing and grinding. After this you have to concentrate the zinc blende ore by froth flotation method. Okay, then you have to convert the ZnS into ZnO by roasting. Okay, so after roasting you have to reduce the zinc oxide to get zinc metal. So extraction of zinc from zinc blende is that is the main step, reduction. Zinc oxide, after getting zinc oxide after roasting, so zinc oxide then reduced by carbon reduction to give zinc and carbon monoxide, and carbon monoxide also act as a reducing agent. So zinc is extracted from zinc oxide by the process of reduction. The reduction of zinc oxide is carried out by mixing it with powdered coke and then heating at 673 Kelvin. Okay, so extraction of zinc, carbon reduction, And extraction of iron, it is also carbon reduction, extraction of iron. Main ore of iron is hematite, Fe2O3. Okay, so from hematite you can extract iron. Okay, first you have to concentrate the iron oxide ore using magnetic separation. So using magnetic separation you can concentrate iron ore. After this you have to calcinate the iron ore, iron oxide ore, that is hematite. Okay, and then in the main step, that is reduction step, you have to reduce the iron oxide by carbon, by coke. Okay, so and the reduction is carried out in a blast furnace. Reduction of iron, all the picture of blast furnace and processes are given in your book. It is a short note type. Okay, that's why picture of the blast furnace I have not given. Okay, so in blast furnace, different zone of blast furnace, there are different type of chemical reactions are occurring during extraction of iron from hematite. Okay, so during extraction of iron, the reduction of iron oxide takes place in blast furnace. In this process, hot air is blown from the bottom of the furnace and coke is burned to raise the temperature up to 2200 Kelvin in the lower portion itself, and the temperature is lower in the upper part. Thus the lower part where the reduction of iron oxide, Fe2O3, Fe3O4 take place, and the reaction taking place in the lower temperature 500 to 800 Kelvin in the blast furnace are these reactions are taking place in the lower portion, taking place in the lower temperature range from 500 to 800 Kelvin. Okay, and the reactions are in Fe2O3 reacts with carbon monoxide. How carbon monoxide form? Carbon, coke burn in oxygen, burn in air to form carbon monoxide. Both carbon and carbon monoxide act as reducing agent. Okay, both carbon. So Fe2O3 actually reduced by carbon monoxide. Fe2O3, that is hematite, calcinated iron oxide ore, is reduced by carbon monoxide, and it will form Fe2O3 plus CO2. Fe2O3 react with CO, again react with CO to give Fe. That is we get iron from iron oxide and carbon dioxide. Okay, Fe2O3 reacts with carbon monoxide to give FeO. Okay, so these are different reactions taking place in the lower region 500 to 800 in the blast furnace. Okay, and the reaction taking place in the higher temperature from 900 to 1500 Kelvin in the blast furnace, the reactions are carbon reacts with carbon dioxide. This is the formation of carbon monoxide I have told. First carbon monoxide is formed in the temperature 900 to 1500 Kelvin, and then FeO react with CO to give Fe plus CO2. Okay, so using this reaction you can get iron from iron oxide. Okay, so and during extraction of iron, coke is used as reducing agent and limestone used as flax, because in the limestone ore some impurities are there. In hematite ore of iron, silica is present as impurity. It is impurity. Okay, it is acidic impurity. So to remove this acidic impurity you have to use a flax, basic flax, and the basic flax is limestone. Okay, so silicate impurity of the ore is removed as a slag by calcium oxide, which is formed by decomposition of limestone. So actually limestone CaCO3 is used as flax, which decompose to give CaO and CO2, and this CaO basic flax, this CaO react with impurities SiO2 to give calcium silicate, which is slag, lighter material, which will float over the iron metal and it will be separated. Okay, so this is carbon reduction of iron in blast furnace. Roll of air, roll of carbon coke, roll of limestone, all you have to read. Okay, now see what is pig iron. The iron which is obtained from the blast furnace contain 4% carbon and many other impurities in smaller amounts, sulfur, phosphorus, silicon, manganese. It is also present in pig iron, and this iron is known as pig iron. Pig iron is the iron obtained from blast furnace which contains 4% carbon and many other impurities like sulfur, phosphorus, silicon, manganese, etc. Now cast iron. What is cast iron? Cast iron obtained by melting pig iron with scrap iron and coke using hot air blast is known as cast iron. Okay, and then wrought iron. Wrought iron and malleable iron is the purest form. It is the purest form of commercial iron in which is prepared from cast iron by oxidizing impurity in a reverberatory furnace with a furnace lined with hematite. Okay, so these are three forms of iron: pig iron, cast iron, wrought iron, based on percentage of carbon present. Okay, all these types of iron you can also read from your book. Okay, now what is added as flux in extraction of iron? I have told limestone is used as flux in extraction of iron. Okay, now see how is cast iron different from pig iron. How is cast iron is different from pig iron? I have told depending on the percentage of carbon. Okay, so the iron obtained from blast furnace is known as pig iron. It contains 4% carbon. So I was telling that how is cast iron different from pig iron. The iron obtained from blast furnace is known as pig iron. I have told before some time, and it contains about 4% of carbon. And many impurities are there such as sulfur, silicon, phosphorus, manganese. Okay, so to obtain cast iron from pig iron you have to remove the impurities present in cast iron. Okay, so cast iron is obtained by melting pig iron and coke using hot air blast, and it contains lower amount of carbon, 3% carbon, than pig iron. Okay, and unlike pig iron, cast iron is extremely hard and brittle. Okay, now see electrochemical principle of metallurgy. It is the extraction of aluminium, but extraction of aluminium is not given in the syllabus, not required. Okay, extraction of aluminium not required. What is the role of cryolite and fluorspar in extraction of aluminium from its ore? Bauxite is not required, excluded from syllabus. Now here you can see different use of different metals. So first, use of copper. Copper is used for making wires used in electrical industry, and for water and steam pipes, and it is also used in several alloys that are rather tougher than the metal itself, such as alloy of copper. Example of alloy of copper are brass, which is mixture of copper and zinc, and bronze, which is an alloy of copper and tin. Okay, so these are alloy of copper. And coinage alloy is a mixture of copper and nickel. You have to remember different alloy of copper, composition and their use also. Okay, use of zinc is used for galvanization of iron, and it is also used in large quantity in batteries, and many alloy you can made using zinc, like brass, which contains 60% copper and 40% zinc, like German silver, which contain copper 25% copper, 25 to 30% copper, zinc 25 to 30%, and nickel 40 to 50%. So remember that in German silver there is no silver is present. It is actually alloy of zinc, copper and nickel. Okay, and zinc dust is used as a reducing agent in the manufacture of dyes, stuffs, paints, etc. And now see use of iron. There are different form of iron: cast iron, wrought iron and pig iron. Okay, so cast iron, it is the most important form of iron, and it is used for the casting of stove, railway sleepers. Okay, and it is also used in manufacture of wrought iron and steel. From cast iron you can make wrought iron and steel. And use of wrought iron, it is used in making anchor, wires, bolts, chain, agricultural implements. Okay, and now see use of steel. These are all are steel is an alloy of iron. Okay, so alloy steel is obtained when other metals are added to iron, like nickel steel. It is used for making cables, automobiles and aeroplane parts, pendulum, measuring taps, in which nickel is mixed with iron. Chrome steel, in which iron is chromium is mixed with iron. Chrome steel, okay, used for cutting tools and crushing machine. And stainless steel, okay, which is used for cycle, automobiles, utensils, pen, etc. Okay, so all these alloy and their composition and their use you have to read. Okay, and how to extract different metals. Thank you, students. This chapter is completed.